Alright, this is the beginning of 15.1, our lesson. It's in your new packet. Alright, so we're going to start. There is some calculator on it, so you're just going to have to trust me on it. When you come back to school, you can kind of play around with it a little bit. Alright, so we have a linear parent function. That is our basic of our linear, which is going to be y equals x. And then we have our quadratic parent, which is the basic quadratic. We're going to be seeing when I take that basic quadratic, that parent function, and I do things to it like add a coefficient or add a constant to it or subtract it or make the coefficient negative, what's going to happen to my graph? Some of this we already know, but let's look at it. So we're going to make a table. As I told y'all, I like to have a couple negatives, a couple positives. I also happen to know where my vertex is going to be, and so make sure that I've included that in my numbers. Alright, so when I take negative 3 and I square it, I get 9. Negative 2 squared is 4. Negative 1 squared is 1, and so forth. And then I'm going to plot those points. If you are new to my videos, the algebra ones, I do make them pretty quickly. I don't want them to drag on, plus you have the ability to rewind or pause if I go too fast. Alright. Connect it. That's not bad. I'm usually really horrible at drawing quadratics. Alright, so our vertex is at 0, 0. Our line of symmetry is going to be x equals 0. Intercepts, our x-intercept is 0, 0. Our y-intercept is 0, 0. Our domain is all the real numbers. And the range is y is greater than or equal to 0. We should be good on all that. It's what we just took a test on. So you should be good on all of those. So now we're going to see what happens when I do some changes. So this is where the calculator came in. And so we had, and I can kind of show you. So we did x squared, and x squared, as you can see, looks like that. And then when we plotted 2x squared, it became like this. And then when I plotted 5x squared, it looked like this. Okay, so what happened there is it got skinnier. It got more narrow, so the class decided I'm using the word steeper. I feel stupid because I don't know if it's an A or an E. My brain doesn't want to work, so steeper. Sorry if that's incorrect. If your mom's an English teacher, don't tell her. It's more narrow. The correct term, though, is that it stretches. Alright. And then we looked at, again, x squared. And what happens when I had 1/2? And what happened when I had 1/5? And I can see that it got wider. And this is called compress. It compresses. Alright? Then we looked at, and this one was a little bit easier, because we've already looked at this before, when I added negative in front of that. So here's my x squared, and when I have a negative x squared, it flips, it opens down, and the correct terminology is that it reflects over the x-axis. Now let's look at number 4. So again, we had y equals x squared. And then when I had y, x, and now I'm adding to it, my graph went like that. And then when I was it went like that. Now, of course, that's not accurate. None of these are really accurate because I'm hand drawing them. But we can see that adding to x squared, it shifted it up. Now, of course, this was when I was adding a positive. But if I subtract or add a negative, subtract from x squared, it shifted down. So those are the 4 changes that we are looking at today. So if you go to the next page, it kind of puts it a little bit into one little thing. So when I'm looking at my a, that lead coefficient, if a is greater than 1, it's going to stretch. The graph stretches. And when it's between 0 and 1, it's going to compress. Compresses vertically. And I'm just going to put when a is less than 1, so I'm going to just put when it's negative. It's going to reflect. Then we'll look at that d, so whatever we're adding to it. So this would be, when we're adding, of course I'm saying adding a positive. Sorry, my phone's on. And it's going to go up. And when I'm subtracting, and by subtracting, this means, you know, when I'm either adding a negative or subtracting a positive, it's going to go down. Okay, so it's a vertical translation. So we have 4 graphs here. We're going to try to match them up. So I started, first of all, some people look at the graphs and then they pick the equation. I'm going to look at it and say 2x. 2x tells me it's going to get skinnier. Okay? It's going to get skinnier. It's going to stretch. It's going to stretch this way. I don't know if you can see my hands. Stretch this way. Okay? And so I'm looking for one that's stretching, and C stretches. And it has a domain, all real numbers, and my range is y is greater than or equal to 0. Number 7, I have a negative, so it's going to open downwards, and I added 2, so it's going to go up 2, which matches D. We've already talked about this. The domain is going to be all real numbers. It'll be that way until we flip that sideways. Our range is going to be y is less than or equal to 2. I do like how someone pointed out it went from a min to a max, which that's true. Alright, so now let's look at numbers. So we have a positive, so it's going to open upwards, but it's shifted down, which matches D. And so that's all the real numbers is my domain. And my range is going to be y is greater than or equal to -2. And then for the 1/2, it got fatter, it compressed. So it's going to be A, domain's all real numbers, y is greater than or equal to 0. Alright, so let's look at number 10. So if x squared minus 7, if f of x, so we're saying this one right here is going to be x squared minus 7. Okay, what is the equation for g of x? So we're going to do g of x, so I started to write y is equal to. Well, did it get fatter or skinnier? No. Is it opening up or down? It's opening up, so it's going to stay positive x squared. And then it is up 2. It translated 2 from my origin, so it is plus 2. How does the graph f of x compare to g of x? Well, f of x is blank units below g of x. So let's see how far it is below. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units below. So we're just making a comparison there. Sorry. Forgot the graph was in there. Number 11, if x squared plus 3 is shifted 6 down. So if you have to come up here and graph where that x3 is going to be, the f of x would be that plus 3, that vertex, and it's going to go down 1, 2, 3, 4, 5, 6. Oh my goodness. 1, 2, 3. It should be right there. Shouldn't use a pen for that reason. Okay. So my graph was f of x. Well, we're going to change it to g of x because it's a new graph. It didn't compress. It didn't compress. It didn't stretch. It didn't reflect. So my x squared gets to stay the same. But it did go down 6, but I'm not going to put minus 6 because it went down 6 from that positive 3. So it is now a minus 3. Number 12, how does the graph y equals 2x squared plus 4 compare to 2x squared minus 1? Well, I can see they have the same coefficient, so I'm not going to have any stretching or compressing. If I look at my answers, I have shifting right and left. Well, we haven't even talked about shifting right and left. So I need to figure out, this one is going to be above, but let's see. If I do my graph, it's right there. My other one is right here. So it's 4, 5 above. You have to graph it to look at it? Go for it. And then number 13, start with the graph y equals x squared and write an equation that will vertically compress it. So we came up with some as a class, so we're going to just use those so your notes match. We said A is between 0 and 1. Stretches any coefficient that's greater than 1. A is greater than 1. Translating up, my x squared is not going to change, but I'm going to add, so they chose 5. So D is added, because it's a positive, it went up. Y equals x squared. Going down is going to be subtraction. They chose subtracting 70. D is subtracted, because it went down. You can also do add a negative, which same as subtract. All right, so that was just us coming up with some examples. You could have put your own numbers there. All right. All right, so for your homework, you do have matching, and then you have give me some domain and range, and then you've got, it's 3 pages. It's got some multiple choice. If you have questions, please send them my way. Y'all have a blessed day.